Okay, start with a story. Once upon a time, Sunday, 9:15. For some reason, the clicker doesn't work. Let's just go for this. Sat at home, just checked my email, didn't think anything of it. A few moments later, I was slightly more panicked. That's because I found this in my email. For those of you at the back or can't see it, I had a budget alert set up for $400, and suddenly there was something that was slightly higher than that. So also looked at the cost anomaly because, again, best practice, set up some of those. And again, that wasn't a great sign. Really didn't like those numbers. So switch off the phone, get out the laptop. And since step functions was the thing that was causing the problem, went to the console. How many people have used step functions here? Okay, quite a few. So this is the executions page. I'm not used to seeing a number quite that big in terms of the number of executions. Lots of errors. So over to CloudWatch metrics and quite a few executions per hour. That's 420 odd thousands per hour. Slightly panicked at this stage, so I decided I want to shut it off. And throughout this talk, I'm going to give a few feature requests to my ex-AWS colleagues in the audience. Please find a way to turn off step functions or disable step functions. You can't. The only way you can do it is delete it. So I deleted it before. Well, I made a copy first. And by this stage, I'm saying, okay, I've constrained the cost. Now, what's going on? So I went and looked at the step function. I'm not sure how many can see this, but lots of people put their hand up. Who can spot the error with this step function? What was the problem? Feel free to shout out. So this was developed by somebody who didn't really know AWS that well, but step functions is a drag and drop editor. Unfortunately, they saw the step function start execution action and assumed they needed that to start the step function. No, it starts at the yellow blob at the top. What the first box does is call another step function. That step function called itself. Spot the problem? So it called itself with a valid ID, which meant it took the happy path through Lambda and then on to success, in theory. But we had a problem. Second feature request, please find a way of disabling recursive activity in step functions. Lambda does it. Step functions team, please do the same. Okay, so now I've sort of got to the point where I've diagnosed what the problem is. I'm trying to think, did I miss anything? Could I have set anything up differently? So I checked, budgets were set up, cost anomaly reporting was set up, reporting for budgets was set up. Third request, please provide an API for setting up budget reports. It's one of the only things I found that you have to do ClickOps in the console to set a daily email. Really strange. But the cost anomaly was set up as well, setting reports and so on. But one thing I did overlook is I set it to do daily summaries. I didn't ask for individual alerts. And the reason I didn't is because it then required SNS, and that SNS would have needed to do something other than email to make it useful. I'm not sure if anyone here has tried setting up notifications in AWS recently. 5-6 years ago, it was easy. SNS to SMS, you're done. I challenge anyone to go and figure out in EU West 1 or EU West 2 to set up notifications nice and easy by integrating SNS and end user messaging, or perhaps as use notifications, or perhaps you're going to use Q chatbot. It's not easy. Let's make that a little bit easier. So why weren't there any alerts? All that was set up, and yet suddenly this thing came in a bit late. Well, if you read the documentation, anyone read the documentation? Yeah, no, I thought so. So this is documentation from Cost Explorer. I'll call the one in the middle. The rest of your data takes a few days longer. Cost Explorer updates at least once every 24 hours. No, it doesn't. So this is a graph from Cost Explorer taken at the time of the event, about 10 o'clock. So you can see normal step function usage on the left. The red bar is about when it started. The blue area, the light blue area, is where there's no data. The red bar on the right is when I received the email saying there's a problem, or when it was received about 2 a.m. And the bar on the right, the final sort of end of the blue section, is 9:30 in the morning. There's an awful lot of data I couldn't see, but there's also a massive gap between when the problem started and when that first alert came in. So I checked back and I missed anything the day before. So this is the budget report from yesterday. Yep, it was fine. Slightly over budget, but that was expected. We were over budget anyway. Cost anomaly. Yep, absolutely fine. The only thing that it flagged was inspector because somebody had started an EC2 instance. Not a problem. So what's going on? When you look at it, the budget summary for Friday was sent at 1 or received at 1 a.m. on Saturday and didn't see any problems. The anomaly alert was received at 3 a.m. on Saturday, didn't see any problems. Remember that delay in Cost Explorer? So there's obviously a lag. It's analyzing data using Cost Explorer from a while ago. That while ago was before the event started. And so that alert for Friday didn't actually show anything. And when you do the numbers, it was about a 16-hour lag in Cost Explorer between when the cost is incurred and when it appears within Cost Explorer. Now, that same data is used for budgets, it's used for cost and usage reporting, it's used for anomaly detection. So something you need to bear in mind. Another feature request, sorry, AWS folks, there's going to be a lot of these. Can we have something that's slightly more granular or quicker? There is an estimated billing capability within CloudWatch. It's only in US East 1. It's only available in the payer account if you have AWS organizations. And really annoyingly, it doesn't show spend if you have credits. So if you're calling down from credits, it shows your spend is 0, which is great if you don't want to burn your credits. So that was the problem. So anyway, by the end of the event, I sort of summarized what happened. And so some of these numbers based on that one mistake in a step function, 45 hours between when it started and when we turned it off. There are 18.5 million state executions in that time. Okay, reasonable. There are 131 million state transitions in that time. So roughly 800 per second. And it's state transitions that cost money in step functions. But it could have been worse. If you look at the quota limits for London region, which is where this is running, there's an account level quota of 800 transitions per second. If I'd been running this in Dublin, that's got 5,000 transactions per second limit. That would have been almost, more than 6 times the cost. As it was, it cost more than £3,000 for that one mistake for step functions. Would have been 20 odd K if it had been in Ireland. But it wasn't just that. It was 6 million Lambda executions that worked. And again, it was a dummy Lambda function, so it didn't actually do anything. Almost 50 million that were throttled because Lambda has a sensible concurrency limit. It used 57 gigabytes seconds of memory of Lambda processing time, which made the Lambda bill £114. Logged 75 gigs of CloudTrail data, which cost 56 quid. GuardDuty was analyzing that CloudTrail log data and analyzed 50 million events. That cost 200 quid. So all in, it was over 3.5 grand for one very trivial mistake that wasn't caught. It's going to hurt. Okay, so that's the story. Just a tiny bit about me. I didn't introduce myself. I'm Matt. I'm CEO at a partner called Rayo. But prior to that, I was 8.5 years at AWS. Prior to that, 16 years at a charity called EduServe. I just realized I've gone through one slide. I judge where I've worked by the number of logo changes that happen throughout the course. So, normally 4 years per logo change, roughly. And I've been working with AWS since about 2011 on a whole bunch of different stuff. So I don't consider myself new to this, and yet there is still quite a lot to learn. Anyway, I haven't mentioned Gen AI yet, so that's that out of the way. Right, so how do we control cost? If this is the problem, what are we going to do about it? Okay, so let's think about what triggers cost in AWS. There are 2 real things. They're control plane API requests. This is when you say, run an instance, create an S3 bucket, create a hosted zone, run an auto-scaling event. Now, some of these are going to be triggered from your users. Some of these are going to be triggered from services that execute things. For example, step functions. Triggered a step function. That was a control plane event. These are logged in CloudTrail almost without exception. But then there's a whole bunch of data plane activity. Now, the data plane is a slightly looser, more vague term, depending on the service, but think of this as things like DNS lookups or data transfer out or data processed by a NAT gateway. All of these things are things that are effectively outside of your direct control because they're based on usage. These might be logged in CloudTrail as a data event. As a data event, not a management event. If you do that, be very careful because that can rack up costs very, very quickly. But more importantly, how do you control these costs? So you can control plane API requests with preventative controls, and we'll talk a little bit about that in a minute. Not always easy, but it's doable. Data plane activity is really difficult to control from AWS using its built-in capabilities. There's some services that help, but in general, it's the key challenge that customers come across with when working with AWS. And so that leads into the concept of cost-conscious design. What do I mean by that? So it's effectively how you think about building things in the cloud cost-effectively. So this traditional server-based infrastructure on-prem, I'm sure most people would have seen this in one way or another. Compute, storage, networking, you buy a bunch of kit, you put it in a facility, it costs you X per year for 5 years. You know what those costs are. It's a fixed cost. Costs are fixed. Performance is variable. If one person using it, it flies. If you have 100,000 people using it, it probably slows to a standstill. But the costs don't change. Contrast that with serverless. And I'm guessing, given the title of the conference, most people here use serverless in one way or another. It's great. You build an architecture, you slot the components in, and performance is fixed. Doesn't matter how many people are using it, it runs. But that means that costs are variable because for every execution, there occurs a cost. And hence, these costs are potentially unbounded. So the problem with unbounded costs is these, as I mentioned, traditional infrastructure has these built-in safeguards. You can't run too much on a set of physical infrastructure. We've all seen it. You run out of disk storage space. You have to make a purchase, go buy some more on-prem, or you need to buy more servers. But that's a conscious decision. It doesn't overrun based on usage. Serverless has that apparently infinite capability of cloud. You run 1,000 queries in parallel. It performs the same as running one, but it costs 1,000 times more. So how do you prevent runaway costs? If you know the answer, please come and see me afterwards because I genuinely don't know. AWS doesn't really give you options at the data plane level, not very easy to implement. You can build your own things. So I've seen solutions which build an API gateway front door that throttle things, that try and build it into the application to authenticate the number of requests per second. But really, you need to build this into your application. There's not much that you can do within AWS. And that even applies if you build traditional infrastructure in the cloud. So if you look at something like EC2, you launch an EC2 instance, it's a fixed price per hour. Sounds great. What about data outbound transfer? What about things like VPC flow logs that traffic to that generates? What about CloudWatch logs? If you're taking logs from that instance and pushing the CloudWatch logs, there's a charge for ingest. DNS queries to get to it in the first place. Snapshots, depending on the rate of data change, those snapshot costs will vary. So even in a traditional infrastructure, and although you can disable some of these things, you don't have to log CloudWatch logs. If you follow best practices, you're going to end up with some type of uncontrolled cost. And so when we look at which AWS services are unbounded, well, it's the cloud. Almost all of them are. Anything that charges for data egress or data processing is going to be inherently unbounded because it depends on your use cases. It depends on how your users are using it. S3 puts and gets. S3 will throttle you at some stage if you do too much. That's a pretty high throttle. You will probably exhaust your credit card before you exhaust S3. And then anything that processes or analyzes data based on usage. So CloudWatch, Config, CloudTrail, GuardDuty, all of these things. As I mentioned, some make an effort. Lambda has throttling. API Gateway allows you to use things like API plans. DynamoDB gives you provision throughput capabilities, but you have to consciously implement them. So with that aside, what can we do about those preventative controls? How do we stop people doing things, at least in the control plane, that they shouldn't do? So IAM and SCP, so service control policies, IAM, identity and access management policies, comprehensive set of permissions. probably too comprehensive at times. It's pretty complex, but gives you very granular capabilities to say what's allowed, what isn't. And with SCPs, you can set those at the organization or the OU unit or the account level so that even if you've got admin privileges, you can protect against some of these things. But there are lots of edge cases, and it's a pretty complicated thing. There's lots of AWS services, I think more than 270 endpoints now for AWS. And within those, there's a whole bunch of actions that occur. So you need to understand which actions do I want to filter on from a cost perspective? How do I control them? What conditions do I need to use, and so on? You can see, well, you can't see, but the statements on the right-hand side are trying to figure out how to restrict you from using IO2 volumes or IO1 volumes. It's not a simple process. But despite that, SCPs are the first, last, and only line of defense against unintended control plane usage. So best practice, for this, if you're using SCPs, and you should, start with explicit allows for services. I know it's a pain because you keep having to add services you want to use, but start there. Add an explicit allow, and every time you do that, implement some cost monitoring for that service. And we'll talk about how to do that in a bit. Then think about how you do explicit denies for features of services that you don't want. So turn off people buying savings plans if you don't want people to do that. Turn off the ability to buy Shield Advance if you don't want to have a 36K bill at 1 month. This is even harder because the controls and the conditions aren't easy to get your head around. AI can help generate those policies. It'll get you 80% of there. It'll always add a couple of actions that don't exist. You have to debug that, but it's generally there. And then what you find is that anything you haven't explicitly allowed or explicitly denied will be implicitly denied, which is good because it means if AWS releases a brand new service, unless you explicitly allow it, it won't come into your environment. It won't be able to be used. I mentioned this is complicated. Anyone want to guess what that is? It is a bit unfair given now given the size of the screens. That's just the action namespace, actions for the EC2 namespace. There's 710 different actions. How many of those have an implication on costs that you might want to control? I genuinely have no idea. And I don't think AWS does either, because I've not been able to find any documentation about it. What I have found, though, is this is the single most useful piece of AWS documentation I've read. I refer to it on a weekly basis at least. It talks about service authorization references for IAM. It goes through every action. It goes through all of the resources it applies to. It goes through the condition keys that are valid, how you can use them. It's a massive, the EC2 page takes about 5 minutes to load, but it's genuinely useful. I touched on service throttling. So a few services give you that ability. So we talked about Lambda, we talked about API Gateway and so on. Throttling will reduce the impact, but ultimately it won't stop it. It's also a case that most throttles are set quite high. AWS is a very, very scalable cloud infrastructure. It's quite difficult to stop that. So what you can do is actually think about alarming on throttles. So when something gets throttled, it should probably trigger an alarm somewhere because it means something's running away. But what I'd really like to see is for AWS to provide a way to lower service quotas. There's a lot of work being done. I think something was released just recently about the ability to automatically increase quotas, particularly in new accounts. If I got a Sandbox account, I'd really like to lower that step functions transition to about 5, not 800 or 5,000. So that's all we can do on the preventative side. So the next thing we can do is how quickly can we react to things? So I mentioned about the lag on Cost Explorer. And I was a bit curious because I've known about this for a while, but I've never really done any sort of digging onto it. So I did. So this is the Cost Explorer data lag measured over 3 days. It would have been longer, but there was a slight problem on Monday or something with AWS. I'm not sure. So what you can see there, the graph on the left-hand side, or the chart on the left-hand side, shows the number of hours behind real time that the cost data is. And the red lines show when that cost data gets updated. So best case, on midnight on the 18th of October, it was about 8 hours behind. Worst case, about 6 o'clock on the 19th, it was more than 25 hours behind. Again, if you're going to be driving alerts and stuff on that, you need to bear in mind 24 hours is a long time in politics, and it's certainly a long time in AWS billing. But that said, it is still useful to have it there. So you could do cost anomaly detection. You can set it to look for a particular deviation from a set amount or by percentages. You can do budget alerts. You can send emails. Just remember that timeliness of data. But actually, probably a better way of doing this, and this does take more work, is to use CloudWatch metrics. So CloudWatch metrics are much, much more real-time, typically less than 5 minutes. And what you can do is you can look through the metric namespace and find those metrics that represent service usage. And then you can start setting alarms based on what that might look like and what you want it to be. You can also enable anomaly detection on those as well. But I don't know how that exactly works. I've not been able to figure out exactly how much of a lag there is. But you can build it on your own. And what it also means is if you know the cost of a service and you know the metrics on its use, you can start working out your own caps. So as a worked example, state transitions, 2.5 cents per 1,000 state transitions. If I'd set a monthly cap of $10 in CloudWatch, I can do some sums and it works out about 9 transitions per minute. If I'd done 9 transitions per minute over an entire month, that would have got me to my $10 a month step function. So what I can do, I haven't done that. I can create a CloudWatch alarm that looks for those metrics. When does it exceed 9, a total count or a sum of 9 executions every minute for 2 out of 3 periods? When I get that, I trigger an alarm and I get it. That graph you can see, there's a red line right at the bottom. If I'd set that alarm up, I'd have been notified about the step function's overrun about 2 minutes after it happened. Lesson learned. And unfortunately, some services don't emit service level metrics. What they do is they emit metrics on a per resource level. But what you can do is use something called multi-source queries or CloudWatch metrics insights within AWS to aggregate that. So you can sum, for example, all of the NAT gateway egress fees into a single value and represent that as a single metric, which you can then alarm on. What you can't do, unfortunately, is you can't do cost anomaly alarming on that, but you can do the general alarm. So that's useful. So again, when I mentioned about when you enable a service in SCP, think about how you could look at the metrics to understand when costs are going to overrun. And then the last set of tools I want to talk about are analysis tools. So we talked about Cost Explorer. It's great for diagnosing problems. And there's a little known switch that you can turn on within the payer account to enable hourly granularity. And this allows you for 14 days to look at costs in a 1 hour period rather than a 1 day period. There is a charge for it, but I've yet to see it go more than about $1 a month for that charge. And it does mean you've got much, much better data to understand when a problem started to occur. The other thing it's launched is the ability to do trend reporting. So month over month, you can see what's changed. But if you're going to do that, if you notice here, all of my differences between August and September are 0. And that's because I've got an account running with credits. And by default, credits are included in the summary. And so the credits cancel out the cost and you get a 0 bill. So remember to enable a charge type, filter out and exclude credits. When you do that, you start seeing some real values. So August 437, September 469. That's true on a lot of things. So it's definitely worth remembering when you do that. And if you need to go beyond that, I don't normally recommend AWS solutions because they can sometimes be a bit out of date. But AWS maintains some cloud intelligence dashboards. It's built by enterprise support. It's fully supported. It's open source. It does cost a bit of money, but you get an awful lot of insight into your accounts. And nice thing is it works not just within an org, but across organizations as well. So if you've got a complex environment, you can start aggregating lots of data. If you're interested in finding out more about that's the QR code for that one. But just search for Cloud Intelligence Dashboards anyway. So some key takeaways. Things go wrong in lots of ways. Everything fails all the time. We know that, but it's not just failing. Things can actually succeed too much. So serverless, infinite loops. Most people have seen a Lambda infinite loop. One of the first things I did at AWS was help an organization deal with a cost overrun because someone had created a Lambda infinite loop. Step functions. Someone mentioned to me just talking earlier, EventBridge is a great way of having an EventBridge event talk to an EventBridge event and causing problems there. And serverless for things that aren't really serverless. So things that don't scale to 0, there might always be a cost there. Unbounded scaling, though, is probably the big one. When you're looking at the data plane, those costs can be really difficult. EBS volumes, that's another classic one. If someone doesn't know AWS and they're coming from on-prem environment, there's such a temptation to create an IO2 volume with 60,000 IOPS. Do that, it's $100 a day for that volume. Please don't do that. Using the wrong storage tier. Again, I've seen people with 1K files using infrequent access, which has 128K, so it treats each file as 128K. It's not good. And then lastly, of course, the hack, IAM credentials leaked. Try to avoid that. So prevention is the best cure. So do the basics. Stop putting it off. And I know what it's like because I've been there. Go into SCP, set up the services you want, enable it across your organization. And then go further. You can do things like disable regions. You can start putting features of services into that list. And once you've done that, then think about responsive controls. So again, do the basics. Create a budget, create cost anomaly reports, turn it on. Remember, they just have a lag. And then for those key services that you've enabled, think about using CloudWatch metrics and how you can use that to report. And really invest time in alerting. So that's 16 hours of cost overrun is better than 45 hours. Ideally, 5 minutes of cost overrun is even better. And then lastly, insights are key. Do the basics. There's a lot of tooling within AWS. There's a lot of third-party tooling. Use that to understand and figure out how you can understand what's going on with your environment and how to prevent things in the future. Cost-conscious design. Think, if you're application developers, if you're software engineers, think about how your application scales and how far you want it to scale. For commercial organizations, it's normally not a problem because if your site suddenly is delivering 10x the traffic or your application is being used 10x as much, you're probably getting more revenue. If you work in the public sector and your site is doing 10x the traffic, you've probably not had an increase in budget. So think about how you can work within those costs. And then continuously review. What was working or what was good practice 18 months ago probably isn't anymore. AWS's rate of change is not getting slower. So that's everything I want to talk about today. I am just going to do a gratuitous plug, sorry. If anyone's not going to reInvent and wants to come and watch the keynote in London, just ping us or follow us. We're running a watch party in London. And other than that, I will also say we're hiring. So if you're interested in AWS, let us know. But otherwise, thanks a lot for your time.